Okay, ladies and gentlemen. Shh, quiet please. Alright, so I'm going to just try to record this lesson because some of the students aren't here, and I'll post this online. Let's hope this works tonight. But in any case, I left off last day doing example number 2, okay, where I asked you to try to figure out the actual fraction that is equivalent to 0.4555, okay? And I hope that many of you saw that we have an infinite geometric sequence that doesn't start with the 0.4, but with the 0.0555 and all that kind of stuff after that, okay? So let's take a look at how we can solve this. I got you started with T1 is 0.05. Can someone suggest to me what R is equal to? What's R in this case? R, I know, but what's the actual number? 0.1, good. So notice it's 0.1, okay? So from here, hopefully you can now figure out the sum of this part, which is just 0.05 over 1 minus 0.1, okay? And for those of you who did that, I believe it's 0.05 over 0.9, and I believe that's 5 over 100 times 10 over 9, which gives us 5 over 90. Okay? Am I right? No? Yes? 5 over 90? Now, by the way, you can always double check your answer by using your calculator and just go 5 divided by 90. Yeah, I think I'm okay, right? 0.555555. It rounds, so I'm okay. But unfortunately, you're not done yet because you still have to factor in this 0.4 from the top. So let us then figure out what this is going to be. So I'm running out of space, sorry. But I'll say 0.45 repeating now is the same thing as 0.4 plus this fraction that we just did, 5 over 90. And then how can we do this? Well, 0.4 is the same thing as 4/10 plus 5 over 90. Change it so that we have the equivalent or common denominator. So I will make them both under 90. 4/10 equal to how many 90s? 10 times 9 is 9, so 4 times 9 is 36. So I believe the answer here is just 41 over 90. And that's your fraction for part 2b. Okay. Once again, you can always double check this by just going and dividing, and oh yeah, it's the same thing. So it's all good. All right. So I hope you did that at home, but if you didn't, I just did it for you. Let's see if we can finish off this next one now. Example number 3. This one's actually pretty straightforward. The first term of a geometric series is 2, so there's your T1. And it says now, in this case, the sum to infinity is 4. So what I'm saying there is that S of infinity is the number 4. And I want you to find the common ratio. So how can we actually do that? Well, this one is a straight application of the formula. T1 over 1 minus R. Can someone tell me what S of infinity is? 4, good. T1 is 2, so you have this fraction. And then you need to solve for this. My suggestion, if you can't see, is that, hey, this is like 4 over 1. We can cross multiply, if you like cross multiplying. So 4 bracket 1 minus R equals to 2. And then I guess you can expand, so I'll distribute the 4. And go ahead and solve for R. Okay. So there you have it. Okay. That R equals to 1/2. Yes. Okay. Example number 4. Now, here I've given you a geometric series, but it looks weird. Because notice there's numbers and letters. But don't freak out. You should be able to still do the same thing. As in, tell me what the first term is. You should still be able to tell me what the common ratio is. And in this case for part A, because I want you to write an expression for n terms, we're going to say n just becomes n. We're not going to change the value of n. So help me out somebody. What's the T1 in this case here? 1. Yeah, first term is 1. How about the common ratio? 4x. Notice 1 times 4x gives you 4x. If I take 4x, I multiply by 4x, I get 16x squared, and 16x squared times 4x also gives you that. So R is equal to 4x. Bravo. Now, with this information, you should be able to write the expression for the sum. Let's quickly review that formula. S sub n equals to T1, okay, r to the power n minus 1, r minus 1. Now, notice I didn't use the infinite one, right? I used the regular sum formula from last day, okay? Because n is not infinity, so don't use the infinite formula. So let's go ahead now and simplify this. We'll plug in t sub 1, that's 1. We'll plug in r. Now, please put a bracket around the 4x, because the whole thing of 4x is raised to the power of n. Minus 1 over, and I guess it's 4x minus 1. And if you want to simplify this just a little bit more, my suggestion is to just leave the leave the 1 outside and not worry about it. Okay, and that's all you have. Okay, and that's your answer for this part, at least for part A. Part A, nothing new. Part B is where it gets interesting. Okay, especially how it relates to our case here in this infinite geometric series session. It says now, for what values of x does the series have a sum to infinity? Now, that's worded kind of poorly. Let me just change the wording here. So for what value of x does the series, and instead of have a sum to infinity, I want to say this. Does the series converge? Okay, meaning the sum, okay, meaning the sum is a number, okay, and not equal to infinity. So really what I'm asking you here is, for what values of x does this series, and it's called converge, meaning you'll get smaller and smaller and smaller until you actually become a number. Yes?
You can't have it equal to like x equals 1 over 4, right?
Why?
Fine.
Okay.
Is that just like, instead of writing converges or diverges, if you ask a question like that?
Yeah.
Or like if x equals 1 over 4, would we just write that it's undefined?
So you have to write down something, right? X equals to 1 over 4 or x equals to half something. But the question is, what is that answer going to be?
But if you did like ask us something and the answer would be undefined, it doesn't go in either of the
Yeah, so you just say none of them. Yeah, undefined. Yep. Now, Megan already suggested to us that we should look at those categories. Let's go back and look at those categories. Page, what page is that? Page 2, right? See these categories here? Divergent, convergent. What did I tell you about a convergent series? It has to have the r being what? Less than 1 or bigger than negative 1. So this is the key fact that I want you to use in this question. Okay, so I'm going to go back now. I'm going to say, note that a convergent series, okay, so note a convergent series has the r value being bigger than negative 1 and less than 1. Okay? So, what is my r in this case? For this question, what is r? 4x. Good. So really what you want to say now is, instead of r, 4x has to be either less than 1 or bigger than negative 1. So all I've done is I've replaced r with 4x, because that's what it is in this case. Now, you don't want to solve for 4x, you want to solve for x, so what do we have to do here? Well, we have to get rid of that 4. What should we do here? How about just dividing every single term by 4? Yeah, so then we get x is less than, what's 1 divided by 4? I'll write down the fraction 1/4. And on the other side, it also must be bigger than negative 1/4. So this is your answer here. Okay, so I'm saying to you all the values of x, which are between negative 1/4 and 1/4, okay, not including it, but just in between, are values of x which make this series get smaller and smaller and smaller and converge. Okay, that's what I'm asking you to do here. Done. Okay. Yes, Megan.
So negative 1 over 4.
But if it's equal to, let's think what happens. Okay, let's say if it's equal to, you plug in x, that becomes 1, right? 4 times 1 over 4 is 1. Agreed?
Oh, negative 1.
Oh, negative 1 over 4, sorry. So that'd be negative 1. And this would become positive 1. This will become negative 1. So the ratio is not negative 1. Well, yeah, the ratio is negative 1. So what happens with your series? It goes back and forth, back and forth, back and forth, back and forth. Going to infinity, what do we have? I don't know. It could be positive 1, it could be negative 1, it could be 0. I don't know. So in that case, when you don't know, it's just, yeah, it's an oscillating series. We just say there's no finite sum. Okay? Nothing there. All right, let's do the last one here. Number 5. Hey, it's that ball question again. Remember that ball question? The ball question, the sadly ball question. I will draw out my lovely picture for you again. There's me, and I drop the ball. Okay, here we go again. Okay, and of course, this is the first bounce. And then what happens? It goes back up, comes back down. Here's the second bounce. Okay, third, fourth. And then in this case, I said, what is the total vertical distance traveled after the 5 bounces? So I want you to tell me up to here. What's this, plus 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 this? What's that going to be? Okay?
Wait, what is a...
Right, the total vertical distance that it travels up to the 5th bounce, okay? Or after the 5th bounce. Now, I did say there's more than one way to solve this, so I'm going to show you both, and then you can decide which one you like better. And then hopefully from there, you can figure out the next part. Estimate the total vertical distance traveled before it comes to rest. Okay? So let me show you the first one, method 1. Okay? By the way, what are these measurements? The first one is going to be 2 meters, right? Going down, 2 meters. What's the next one after that? Since it goes up to 70% of its previous height, take your calculator, take 2 times what number? 0.7, good, which gives us 1.4, okay. And then what's next? 1.4 times 0.7, sure.
Oh, 70%.
Yeah, 70%. So the next one is point what? 0.98, okay. 0.98. So 0.98. What's the next one after that? 0.686, okay. 0.686. Next one after that? 0.4802, okay. Plus 0.4802. Maybe I'll move it over. 0.4802. Yes.
Wouldn't that be after 4 bounces?
What is the total vertical distance traveled after?
Because it's just after 5.
Yeah, so I think what I mean by that after the 5th one is right after the 5th bounce. So it's right there, stopping right here. Right, if you go this, and this is like the 6th bounce and 7th bounce. What is the total vertical distance traveled before 5 bounces? You want me to say before? It's just right there, stopping at 5. Okay. Now, I heard some of you or not muddle, but murmur. Thank you, murmur. Why did Mr. Lee leave all that space there?
Oh,
So you're going to make me use white out now.
Well, remember I asked you for total vertical distance? Down, up, down, up, down, up, down. So guess what? I want you to double the 1.4 because you have both up and down. I want you to double the 0.98 because there's up and down. And there's 0.686 that I want you to double because there's up and down. And there's also the 0.4802 that I want you to double because there's up and down. Okay, this is your sequence that you want to add together. Have fun. How can we do this? Okay, now I will show you 2 different ways. I know you can do it by calculator and punching it in, but if I change this to like 50 bounces, you'll be here for a long, long time. Good luck. So what can we do here to help you out? Let me show you 2 ways. Megan, yes? Okay, which formula are you going to use?
I multiplied like the regular sum of a geometric series with 2, and then I subtracted the initial.
Good. So this is what Megan did. Megan says, hey, look, Mr. Lee, everything is doubled. Except for which one? The first term. So Megan's method, or what's called method number 1, is to just take the sequence 2 plus 1.4 plus 0.98 dot 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 all the way to its last term. Okay? And she is going to multiply that by 2. Why? Because there's both up and down. But because there was no up and down for, there was no up and down for that first piece, there's only the down part, what she's going to do then is to subtract 2 at the end. Does that make sense?
Yeah.
Okay. Let's go ahead and solve this then. 2, and then now what's this stuff in red? Well, guess what? That's just the sum of a geometric series. I'll use that formula. 2 bracket 0.7 to the power of, how many terms are here, by the way? 1, 2, 3, 4, 5, right? Minus 1, all over 0.7 minus 1, close the bracket, and then don't forget to minus 2. You're confused? So this whole formula here just represents the sum of these terms in red. Okay. So go ahead and use your calculator, please, and punch that in and see what you get as your answer. Okay, I got 0.7 to the power of 5 minus 1 times 2 divided by 0.3. Oops, should be negative 0.3. So 5.5462. Okay, so I will do this. That equals to 2 times 5.5462, and then you're going to minus the 2 afterwards. So go ahead and do that. Lovely 9.0924. Okay. And I believe this is the correct answer, so congratulations. This is one way of actually calculating this total vertical distance. Okay. Give you a chance to write this down, and then I'll show you another method, method number 2. And you can decide which one you like better. Okay. Okay, now, here's another way of doing it. Can anyone see a different way of looking at this sequence up here again? Instead of using the whole thing and multiplying by 2, I'm going to ask you which terms do you see the up and down? Well, it starts here at 1.4, right? And then it's also 0.98 and all these. So another way of doing this is, let's ignore that first one. Okay, ignore. And here's what I'd like us to do. Okay, so here's method 2. Here's the first term, 2, we'll keep it like that. And then I'm going to ask you to look at these terms, 1.4, 0.98, 0.686, 0.4802. And what do you notice about these terms there? The 1.4, the 0.98. You've got the up and the down. Up and the down. So what should I do with this whole thing? Let's multiply it by 2. Because these are the terms that go up and down, right? The first one doesn't. The first one just goes down. So I left that outside here. That's the first term. Left it out there. Okay? So now in this method, what I'm going to ask you to do is just find the sum of those 4 terms in black. And of course, we can use our sum formula. So what's our sum formula again? It's T1. Now what's T sub 1 in this particular case? If I'm just looking at these terms here. 1.4. Good. So it's now 1.4. Bracket 0.7. To the power of what in this case? How many n's do we have? 4, I heard. Good. Okay. So I'd like you to calculate it this way, and let's hope that you get the same answer. Okay. So once again, 2 different ways to do the exact same question. I don't know which one you like better, but find one that works for you and use it. Times 2 plus 2. Same answer? You bet. Okay. Same. Okay. Now, just as a quick poll, how many of you like the first one? How many of you like the second one? How many of you like both? How many of you don't care? Okay. All right. So I'd like you now to, it doesn't matter which way you use, I want you to solve this last one here. Estimate the total vertical distance the ball travels before it comes to rest. So now I'm saying this. Here's your picture. Here's your ball. Comes down, goes up, down, up, down, up, down, up, down, forever and ever 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 and ever. What's going to happen to your ball sooner or later? It's still going to bounce, right? But it's going to be so small it looks like it's just coming to rest. So when I say comes to a rest, what is n? Thank you. N equals to infinity. Okay. So now what I'm saying is this is an infinite geometric series. Okay? Now, go ahead and try to solve it, please. I'll give you some time to solve this on your own. Solve. Method 2 then. Okay, so I will use method 2 to help you solve this one. Method 2. Okay, method 2 once again says the following. We're going to start with that first bounce, which is 2. And then every other bounce after that has the up and down feature. Right? So I'm going to write down the first few terms, and I'm going to say dot, 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 dot forever. And because there's up and down, I'm going to put a 2 in front of that. Okay, this is the up and down. So when you actually now try to solve this question, you're trying to find the infinite geometric series sum of 1.4 plus 0.98 plus all that stuff forever and ever and ever. And this is where you use your infinite geometric series formula, where T1 is 1.4 and your common ratio is 0.7. Okay. And I will ask you then to double this and then add the 2 back in front. And then let's go ahead and try to solve this now. Calculator time. 1.4 divided by bracket 1 minus 0.7 times that by 2 plus 2. And ladies and gentlemen, I think Graham and Hisham got it. 11.3 repeating meters, or if you like fractions, 11 1/3. Congratulations, gentlemen. Okay. All right, so now you should be able to do